So we're going to check the internal calibrations on a Medlite C6 Hoya Bio Q-switched tattoo removal machine. So we're plugged in, we're powered up, and turn the key on, and we're going to go through some internal checks to make sure that our safety shutters are operating properly. Okay, so now the system's warmed up, we're in standby, and we're going to go from 532 to 1064, and we're going to put our spot size at 3mm. And we press this little orange button here to go to our ready mode. And in checking, what we want to do is run the fluence as high as it will go at the smallest spot size, which is 3 in 1064. And we're hoping to get to 12 joules per centimeter squared. And we have 12 joules. And if it calibrates properly, the ready light will stop flashing and go solid. And it does, so it does calibrate to 12, which is what we need. The next thing we want to do is go to the next higher spot size and check to see what the maximum fluence is at that spot size. Again, when the ready light starts flashing, it'll tell us that we've calibrated at 9.4 joules per centimeter squared. One more time to 6mm spot size. And 4.4 joules per centimeter squared, it calibrates there. And our last spot size on 1064 is going to be 8mm, and it should calibrate to 2.4, and it does. So now what we want to do is go back to 3, but we want to change our frequency from 1064 to 532, and want to run again the fluence up as high as it'll go, and it should go to 5, and it does. We're good at this point. So now what we want to do is go back to standby. Okay, and what we're going to do is we're going to take the collar off, and we're going to get an error 51 when I take the arm off, because there's a little micro switch in there that tells us that the arm is not there. And there you go, error 51, just as advertised. So we're going to bypass the micro switch with a piece of tape. Don't do this at home. This is not recommended. So let's make sure that the switch is fully I don't know if you could hear that or not. You could hear a click, 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 click. And that's a safety shutter, making sure that it does open and close, and that the system sees it open and close. So now we're going to take the top off. And to take the top off, 2 screws in the back, you undo those, you lift it from the back, and then slide it back and lift it up. You'll see there's 2 holes here, and there's 2 little pins here. If you just lift it straight up, it'll break those pins off, and that's something you definitely do not want to do. Okay, so we hang our faceplate off to the front. Everybody calls this a roasting pan for some reason. So we're going to take this off so we can get to the laser deck. So here we see the laser deck. And the components are, this is the total reflector in the back. This is our Pockle cell, Q switch. Polarizing lens. This is the laser head. First turning mirror. And then our optics here. This is our second turning mirror here. Sliding stage. When you're in 1064, the beam is going to go through and go to the right of the sliding stage and go straight out into these optics here and then out through the head. Okay, so we've checked all the internal power, and we know that everything calibrates on 532 and 1064 from a user standpoint in every spot size. And what I did then is I took a shot directly out of the head. You can see that shot is a nice circle and gray. Before, we took a shot out of the handpiece, and although it was a smaller circle, it had black in the middle, which told me that I've got a mirror inside the arm that has a burn spot on it. And so now we just need to find out where that mirror is and replace it. And we should be fine. Once we replace it, we'll take readings directly out of the arm to make sure that we have the fluence out that we need. So this is one of the mirrors out of the arm, and you can see that there's a huge burn spot in the middle. And not only is it burned, normally it burns off the reflective coating or the anti-reflective coating on the mirrors. This one took a little bit further. There's actually glass missing. So it got hit pretty hard. So this mirror is going to have to be replaced. So when we first got the system in, they did some test shots, and we came up with this. And you can see these little spots. They're not. They don't have good coloring throughout. You got little spots in them and all that. So we knew that we had an optic in the arm that was burnt. We replaced it, and now I'm going to fire it on this black paper, and you'll see that there are no white spots in the center or anything, so we've got a nice uniform coloring. So we've tested it. We've got a good round mode. And so what's left to do really is just to check the internal calibrations. And I'm going to stow the arm again because we're not going to need it for a while. So in doing internal calibrations, this particular tattoo laser is based on the 1064 nanometer wavelength. 532 is a derivative of 1064. It actually doubles the frequency. So what we're going to do is we're going to check the base frequency first. So we're going to go to 1064, the smallest spot size, which is 3, and we're going to run our fluence up as high as it will go, and it should go to 12. And when it gets there, our little ready light will flash, and when it becomes solid, it says, I've calibrated, checked everything, and yes, we do have 12 joules per centimeter squared at 3 millimeter spot size. The next thing we do is we go up 1 spot size to 4. So what it does now is it drops the fluence to 9.4 because we've got a bigger spot, and we've got the same amount of energy that we have to spread over a larger area. So it does calibrate to 9.4, which is great. Go to 6 millimeter spot size, it goes to 4.4 joules per centimeter squared. It calibrates great. Our largest spot size, which is 8, and it should calibrate at 2.4 joules. And it does. So now we know that our base frequency of 1064 is solid. Now we're going to go to 532. We're going to go back to the smallest spot size, which is 2. But on 532 at 2 millimeter, the largest fluence we can get is 5. And if you hold the up button, it won't go any further. It stops right at 5. And it should calibrate. 532 takes a little longer to calibrate. It does. We're going to go now to 3 millimeter, and it stays at 5. And then we go to 4, and it calibrates. These calibrations should be done about once every 2 to 3 weeks, just to make sure that everything is staying steady. And we'll provide these numbers to the client who purchased it. So when we first got it in, we found out we had a bad arm mirror. We replaced that. We went through the deck, realigned everything, put the arm back on with the new optic, made sure that the beam was coming straight up out of the arm. We did something called a spin test to make sure that that was done. We made our adjustments there. We put everything back together. We checked out our internal calibrations, and now this unit is ready to be shipped to a customer.